Hello and welcome to the Daily Space for today, July 25th, 2019. I'm your host, Dr. Pamela Gay, and I am here to try really hard to put science in your brains. Now, those of you who are watching this live over on twitch.tv/CosmoQuestX are getting to experience, along with me, no manner of technical difficulties. And those of you watching this over on YouTube may or may not be experiencing the fact that the audio has decided it will only be on the left. I have no idea what is going on. Well, I have one small idea of what's going on. I'm working to use Wirecast software, and for reasons that I haven't figured out yet, it wants to only have one side of the audio. So instead of trying to fix the technical difficulties, I'm instead going to switch on over to trying and hopefully being far more successful in bringing you all the science, because that's why we're here. In today's first story, I have a story coming to us from the Zwicky Transient Factory. And normally when we talk about the Zwicky Transient Factory, we're talking about the discovery of new supernovae, we're talking about new asteroids that have been found. Well, this particular instrument out at, Mount Wilson Observatory is working on detecting everything that flickers, flares, and moves in the night sky. And this happens to include variable stars. And today we have the most amazing of, in this case, two stars acting as one variable object. This is an eclipsing binary made of two perfectly normal white dwarf stars that are getting a little bit smaller of an orbit every single day, and that's what makes them interesting. Discovered by the Zwicky Transient Factory and observed in detail by the Kitt Peak 84-inch telescope, or 2.1 meter telescope. This system, which is cataloged with the fascinating name of ZTF J1530 plus 5027, this system could actually fit entirely inside of Saturn. Both stars, their orbit, everything could fit inside of Saturn. The stars have roughly 20% and 60% of the mass of the sun. And the way white dwarf stars work out is it's the more massive one that is smaller, because that additional weight has been able to, crush it more under the force of gravity. Both stars are a little bit bigger than the planet Earth, and it turns out that it's the larger 20% the mass of the sun, fainter star that is making this story so interesting, because that fainter star passes, from our perspective, directly in front of the brighter star, eclipsing it, rather rapidly. In fact, every 6.91 minutes, there is an eclipse. That's two stars, each slightly bigger than the Earth, orbiting every 6.91 minutes. And what's really cool about this system is it's generating gravitational waves that are going to be detectable by the European Space Agency's LISA mission as soon as it's able to finally get launched. Now, LISA is a mission that NASA first announced back when I was still a grad student. It is now scheduled, not by NASA, but by the European Space Agency, to be launched in 2034. It will be carrying NASA components on board. This system that we're looking at, this pair of binaries, this pair of white dwarfs in this binary, they're radiating away gravitational energy as the stars creep 26 centimeters per day closer together. It's a low frequency gravity wave, and it should be near the peak of LISA's sensitivity at 4.8 millihertz. So this is just a cool system. It's tiny, it's bright, it's dead stars doing their dead star thing, and it's radiating away gravitational waves, and it's going to be detectable in what we call multi-messenger astronomy. in, well, about a decade. Well, a decade and a half, to be fair. So this is kind of cool. So, well, going from dead stars to stars being born, we have a tale of trying to figure out exactly why so few stars are born. Our galaxy is undergoing, well, problems with a low birth rate. It may not be problems, it depends on your perspective, but however you look at it, the truth is, our galaxy only is forming a handful of stars per year. And we know that our galaxy is completely chock full of gas and dust because it's blocking our view of so much cool stuff. Well, when astronomers from the National Astronomical Observatory of Japan used their Nobeyama Radio Observatory to probe the density of gas in the Milky Way, they found that the problem is actually one of, well, low gas density. In this case, what they found is the sky is filled with stars. It's filled with gas and dust, and most of that gas and dust is just not dense enough to collapse into stars. In fact, only about 3% of the gas and dust they were able to observe is capable of forming stars. So yes, there is gas everywhere, but unless something smashes into it to make it much denser, we're looking at limited star formation being the norm far into the future. Now, continuing our discussion of gas and dust, we're going to close out today's episode with the case of missing matter in a nearby galaxy, or in this case, what used to be two galaxies, and how that missing mass was found with the MeerKAT radio telescope set down in South Africa. The distorted galaxy NGC 1316 appears in optical images to be the result of recent galactic collision. This conclusion is supported by its bright radio emission, which makes it actually the fourth brightest radio object in the sky and earns it the name Fornax A. This radio emission hints at wild star formation and an active black hole, both of which are generated by gas getting driven in to the center of the colliding galaxies as the new galaxy ends up forming and settling out. The thing is, otherwise, this galaxy appears to have much less gas content than what would normally be expected. Now, in this image that I'm showing you here, I really wish they'd used color. So you can see in the background of the image shades of gray that appear to be a really nice crisp photo, and that's because that's an optical image of NGC 1316. Now, overlain on top of this optical image is slightly blue-gray, digitally created, cartoony-looking blobs, and that's the radio emission that was detected by MeerKAT. By adding up the mass of all of the gas in these new MeerKAT observations, they were able to show that the gas was actually torn out of the merging system, and these two otherwise invisible arms of gas are where all of that material landed. Now, I say these arms are almost entirely made of gas, but the reason I use the word almost is because they also are rich in stars that you can't actually see in this particular optical image. So when the material is all added up, those exiled stars, all of that exiled gas, and everything in the optically visible galaxy merger thing, you find all the material that was originally in those two galaxies. This is just a nice case of observationally sweeping together all the debris of two colliding galaxies, the same way you might pick up all the debris from a broken light bulb. Sure, most of the chunks land in the middle of the, well, destruction, but some of those pieces get swept out in the, well, destruction that occurs when things get broken or merged together. Now, one of the really cool things about this is it shows that MeerKAT has the potential to do slow and steady, detailed work in measuring our skies that allows us to see things deeper and fainter than we have ever seen before, which is amazing on its own. But when you realize that MeerKAT is just a technology test, a precursor to what we're going to be able to do with the square kilometer array, well, that tells us the best is really yet to come. So that's today's science, and I am so glad to have something that is not moon related. So here's to seeing more and more papers come out, and we do expect to see an increase in science as the summer progresses, as more and more professors are like, oh my God, I have to get everything done before the semester starts. Because sometimes that's kind of the way, well, we all get motivated to finish up our projects. So now, switching over to having dogs in the background, I am going to take all of your questions and remind you of three things. First, at me, at CosmoQuestX. Second, today we're dealing with a slightly broken setup because I'm using Wirecast and I don't quite have everything set up just yet. And 3, we are a production of the Planetary Science Institute working in collaboration with Youngstown State University. We are brought to you by you. We are here thanks to your donations, your patronage over at patreon.com/CosmoQuestX. And it's because of you that Annie and I can do this day after day. And in fact, we come to you most Mondays through Fridays at 1 p.m. Eastern. That is 6 p.m. London, 10 a.m. Los Angeles. And on Sundays at the same time, Annie brings you the Sunday Science Hour. Now, when we're not bringing you these regularly scheduled shows, you can also catch us bringing you launches, landings, and, well, everything in between. And sometimes, right now, we also bring you rage mapping of the asteroid Bennu. The best way you can help us out in this very moment isn't necessarily money. Money helps. Oh my God, we like to be able to get paid. But we're trying to finish mapping a hellscape of rocks and boulders that is called Bennu. And we're trying to find the best place that the spacecraft OSIRIS-REx can do a grab and go, getting some soil to bring back to our planet where we can, well, study it in a lab. So please, go to bennu.cosmoquest.org and help us rage map an asteroid. Okay, that's really all I've got to say. So now I'm going to scroll back and see what questions you have to ask. I'm so sorry I started with so many technical difficulties, and oh my God, how is it 37.8 degrees Celsius in Germany? I'm sorry, Guido, that you're dealing with 40-degree temperatures. You guys just don't have the air conditioning to deal with that. That is terrible. Oh, an all-time high of 42.6 Celsius today. Wow. Yeah. Here in the U.S., places like Phoenix and Tucson will get all the way into 50s, and I just don't understand how people live there. Yeah. Wicked Wander is commenting that they saw a dress with feet walk by in the pre-show. Yeah, I forgot I needed to close the blind behind me so I wouldn't be backlit. The Gem Doctor is commenting that it's 20 degrees Celsius there in Vancouver. I wish we had that. Okay, let's see. Lots of comments about me being muted. Yes, all the technological difficulties, all of them. I'm working to get it fixed. And JB McCool, I totally deserved that F for fail. Let's see. So Henny's Verb asks, would they explode when they touch? Will they ever touch? And this is a question related to the binary white dwarf system that we had at the beginning. Yes, these two stars are eventually going to merge together and go supernova most likely when they do, which is kind of awesome. Supernova may be too... Actually, no, sorry, that's a lie. They don't have enough mass to go supernova. Their total mass is less than the mass of the sun. So ignore what I just said. They are eventually going to come together, and as they get closer and closer, it's going to poof out their outer atmospheres. And those cores are going to end up orbiting each other as the outer atmospheres of the stars poof out. And this entire thing gets resurrected as a new kind of star. There's some theories that think that our Corona Borealis stars, a type of variable star, may be these merged white dwarfs that we're now seeing. This system, though, will merge and in the process poof out a joined atmosphere while the cores work on getting closer and closer together. Sorry for the initial misspeak. 2 neutron stars will go supernova. 2 white dwarfs just poof out to form a new singular star. So Henny's Vorverb asks, how much longer will Lisa be able to hear gravitational waves as opposed to LIGO? So the way to think of it isn't how much longer will one be able to hear things than the other, but rather that they're hearing different notes. So LIGO is able to hear the notes that come from extremely high mass objects in the final moments before they go supernova. Lisa is going to be able to hear the day-to-day notes that are made when things like these 2 white dwarfs are in the process of merging. So they hear different frequencies. You might say that LIGO hears the piccolos, while Lisa's going to be hearing the bass clarinet playing that long note for long periods of time. So let's see what other questions we have. Henning goes on to ask, with all the collisions our galaxy has been through, what percentage of its stars are not in the disk? So I don't know what percentage of stars have been ejected from our galaxy. Our galaxy is more of the habit of consuming smaller galaxies in its recent past. So a better question is, what fraction of the stars in the disk have been stolen in the past few billion years from other galaxies it's cannibalized? And I don't know the most current number on that, but last time I saw the number, I don't remember what it was, but I remember it was much larger than I remembered. Yeah, so we're more of a thief than an ejector. Let's see what other questions we have. J. Sierra asks, hi Pamela, I'm an incoming undergraduate transfer student to the astrophysics program at the University of Minnesota Twin Cities campus for this fall. Any tips for someone looking to pursue a graduate degree one day? Find a faculty member that you like, and this is actually sometimes more important than that you like their research. Find a faculty member who you think you can really get along with and who can mentor you, and ask them if you can do research for them. Start out, if they don't offer you money, just doing it for free to get the experience, and then work towards becoming a paid intern if you can. That research experience is really what will get you into a graduate program. Also look to apply for undergraduate research experiences in the summer. These are paid positions. They're called REUs, Research Experiences for Undergrads. Just Google REU. Apply for those programs. They're really hard to get, I'm not going to lie. But the more things that you can do to show that you're capable of doing research, the easier it will be to get into a graduate program. Unfortunately, getting into graduate school is in some cases more competitive than getting tenure as a professor. There are universities where to get tenure as a professor, you need to have submitted a paper and applied for grant money. Whereas to get into a graduate program, you have to be a first author researcher. And that's really discouraging, but it's the reality we live in. There are more people applying for those PhD positions than can possibly be taken. So do as much research as you can. And because that was depressing, I'm going to bring back the puppies in the background. Okay. So Falco Online is commenting, I once heard that some matter gets created in a first type of supernova and another part of matter in another type. But one rare type of metal gets created in one particular type of pulsar. Okay, so there's a whole lot of ideas coming together. So different kinds of atoms are created at different temperatures, at different densities, in different amounts. And so whenever you hear someone saying this atom is created, what they're actually talking about is the majority of this atom is created. So gold gets created a whole lot of different places, but the primary place that gold gets created is when two neutron stars, which can be but don't have to be pulsars, when two neutron stars collide, you get the bulk of gold being formed. Other matter is more likely to get formed in type 1a supernova. Other types are more likely to get formed in type 2 supernova of one type or another. And in our own sun, we're getting carbon, nitrogen, oxygen, all of those things being formed. So there are people who spend their entire career observationally and theoretically trying to figure out what ratios of different atoms are produced in different places. That can be an entire career. But yeah, every different kind of merger, every different kind of explosion, and every kind of star produces its own ratios of heavier and heavier atoms. So let's see, what was the rest of the question? So I think I've told you everything I can easily say about that. So Q23 is asking, do you know how many sources of gravitational waves LISA will detect and how well it would be able to track individual sources in the galactic noise? So tracking, once it finds something, I think it's designed to be able to do that, but I don't know the details. The problem with LISA is its design still isn't fully set in, and what it's able to do has changed so much over the years that I gave up keeping track of it. So check their website. It will probably have more recent news, and the Wikipedia page, I hate to say it, but is probably the best source of information. Uncle Bill Druin is going, wait, what? How does an electron degenerate end-of-life classification like white dwarf poof out? So if you add heat to a white dwarf, it's just a gas. And how big or small the white dwarf is depends on its temperature. So over time, white dwarfs, which on the inside are electron degeneracy pressure, and on the outermost layers have some thermal parts. Well, how much of it is thermally supported gets increased as you heat it up from the outside. So as you add heat to the system from the outside, more and more of the outer layer of the star goes from being an electron degenerate gas to being a normal gas that is supported by thermodynamic effects. And that transition point from electron degenerate gas to normal gas, as more and more of the star becomes normal gas, you can actually end up reigniting this thing as the two cores merge. It's crazy. I'm surprised we haven't done an Astronomy Cast episode on that. I'm adding that to my list of things that we can do a show on. Note, do AC on white dwarf plus white dwarf merger. Yeah, it's cool. Let's see what else is in here. Route 2, no Space Force. Space Force bad. Too soon. So the new heat is actually coming from the two stars are both radiating energy, and when they get close enough, they heat each other up. So it's the two stars are heating each other up. So yeah, thank you for the follow. Okay, so I think that gets me through all of today's content. I am going to work really hard to fix this setup so that everything works way better tomorrow. Thank you for your patience with all of my technological difficulties, especially the unknown all audio is on the left problem. I am displeased. We'll get this fixed. We will get this fixed. Now, the other thing I don't have working yet, but let me see if I can get it working, is the credits. So one moment while I add that in. So your patience is so greatly appreciated today, everyone. So very, very appreciated. Thank you, Trekker Kev. Thank you. The sum is more than the parts. That often happens. And yes, Stella did awaken, sort of. Sometimes that's all you get is a sort of awake. But it's better than not awake. I'll take it. So let's work on getting the code for this. Sorry, I am almost done adding credits. Now comes the special question of, will they roll? Working on it. Give me a moment. So much chaos today, so much chaos. Roll live. It's doing nothing. Come on, roll live. I ask you nicely. Why are you not rolling live? Okay, I am just going to be confused. So I shall instead read out all the good things that have occurred today and say thank you. Thank you, Trekker Kev, for the bits. Thank you, Rurutu, for the follow. And thank you, Rocco Robotics, for the Tier 1 subscription. And Roadster Tracker for the follow. Thank you all for being here. And as always, this has been the Daily Space. We come to you most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific. That's 6 p.m. London time. On Sundays, Annie Wilson brings you the Sunday Science Hour, and as they happen, we bring you all the cool and exciting launches, landings, and everything that appears in between in our solar system and beyond. So check it all out by giving us a follow and finding out when we go live. I will be back tomorrow. And until then, wherever you are in the world, have a fabulous morning, evening, or afternoon. And I'm going to go ahead and raid Oh Bother. So thanks, and I'll see you all on the other side.